Hey guys, welcome to day 14 of the challenge. As you know, I'm doing a 28 days data science AI Gen AI challenge where I'm going ahead and trying to explain different concepts within this concept of data science, AI and Gen AI. So today I'm going to talk about convolutional neural network. Okay. So before I explain what is convolutional neural network, let me try to give you an example of, for example, when you go and try to see a system where it is able to identify whether the given image is of a dog or a cat. So behind the box, what it is trying to do is a CNN, a convolutional neural network system, or is trying to run that thing behind the box. Okay. If you take this idea ahead, right, it can be used for surveillance, it can be used for healthcare, there are multiple applications around it. Okay. So it's me again, Mahesh, having experience of data for 14 years, being a data architect, data engineering, data scientist, data trainer too. So let's dive in and try to understand what is CNN. So now, in the last video I have explained about what is an ANN, right? So if you can always ask me, like, if we know ANN, why can't we do the same thing with the help of ANN? Why can't we take the image, put the image information in the ANN and take it ahead and try to do the classification or whatever operation which we know? But the problem of ANN is that if we try to do it in a similar manner, try to understand the data what we have. The data is of image. Okay. Image can be considered, can be tried to identify with the help of a pixel. Okay. And a given image, a normal colorful image, would have three matrices: a red one, a blue one and a green one. Okay. And if I take a normal image of 180 by 180 pixel with multiply by 3, the total number which I get is somewhere around, which is 349920, right? Which is somewhere around 3 million input features are going to be there at the end. So if I'm using a normal ANN, I have to take this 3 million input feature and go ahead and try to create my neural network, which is going to be very expensive computationally, right? And there's a very good chance I'm going to do a overfitting around it. Okay. And it is, when if I continue to do it also, there's a very good chance the last solution which is going to be there, it's very difficult to deploy that solution. So we have to do something different. So what is the different thing what we have done is a convolutional neural network. So basically what we have done is that in a simpler manner, we are going to do some kind of processing of the data before I go ahead and give it to a neural network. Okay. So it is going to have a convolution layer, a pooling layer and a fully connected layer. Fully connected layer is nothing but the ANN at the end. You can put forward at ANN. You can see it here also. It's a ANN at the end. Okay. So let me try to explain what is a convolution layer and pooling layer. Fully connected layer is something which you already know. A convolution layer, technically what it does is that it tries to identify the important feature within the image. To do that, it uses something called a kernel or a filter. So what it's going to do, so for a given image, it is going to go ahead and try to traverse across the image, and it is going to give you a resultant. The resultant is going to be much more better value or better output of it, where it is going to understand, for example, if this is my image, right? There can be kernel to identify where is my eyes, where is my hat, where is my eyes, where is my mouth, where is my other information of the given face. So there are kernels can actually go traverse across my image and try to find that thing, and the resultant would be something called a feature map, which I have given at the end. I've showed you in a different example also. Okay. So this is something what happens in a convolution operation. Okay. So this is something what I have showed you as an example. So this somebody has written 0 around it. Okay. And if I use a kernel, let's say the kernel is something like this, and I can traverse the kernel across the board. Okay. And try to extract the important information around it, and the resultant what I'm going to get is a feature map. Like this, a feature map. Okay. So if you understand this, the next one is called a pooling layer. Okay. In the pooling, like for example, this is the information what I have received from my feature map. Okay. These 4 information. In that, I'm going to identify which one is the most important information which I have to take it forward. For example, I can do, there are 2 operations. I can take a max pooling or I can take an average pooling. Okay. So technically what I'm trying to do is that I have an image. I've taken the important feature of that image. In that important feature, which one is more important than? Once I get all this information, right, then I can go ahead and try to put forward in a fully connected layer. I can do my my solution. Okay, so this is a very quick recap of what we have done. So this is an image. I'm doing a convolution around it, which has kernels or filter, which goes traverse across and try to give me a resultant. I'm going to do a pooling, and this here also remember that our activation function, which is working behind the box to identify patterns and all. Okay, and then the resultant is going to go to a fully connected layer. Okay, fully connected layer is nothing but the ANN. Okay, it is going to have neurons, it is going to have hidden layer, it is going to have the output. Okay, the connections, the transformation, the classification is all same. So here also I'm going to understand the transformation operations, which I have already know about, like Adam and all. I'm going to use those stuff in the fully connected layer. So everything is same in the fully connected layer. It is like the ANN itself. Okay, so if you want to know what is the ANN, you can go back and see my previous videos and you will be able to understand. Okay, so the applications I have, as I've already told, the applications can be for security purposes, can be used for self-driving cars, can be used for healthcare, can be used for social media, for tagging the images and all, right? I have seen there are a lot of examples coming forward in self-driving cars, of course the Tesla self-driving thing. So it depends upon the CNN. So that's how I can say that CNN is a very important deep learning model which you should know when you go out. Okay, so in the next step, what I'm going to do, I'm going to do a code around the CNN with the help of TensorFlow and PyTorch to make sure that you are able to understand and do the code at the same time. Okay, so this is something what I'm going to do today, and I sign off. Thank you. If you have reached till here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement, and enthusiasm make this journey even more exciting for me. If you found this valuable, drop a comment, share your insight, and tag a friend who should join us. Let's keep learning, building, and growing together in our AI engineering space. Make sure to like, subscribe, and stay tuned for the next challenging stuff what is going to come tomorrow, because we have just started and it is going to get better and better as we go. Bye.